Hi everyone, welcome to the next session of design and drawing of reinforced concrete structure. In last class, we have discussed about the limiting depth of nodal axis or maximum depth of nodal axis. That means if you take any rectangular beam, after taking up this rectangular beam, where the compression phase as well as tension phase is changing due to the providing of grade of steel that we are discussed. If you see in last class, we have taken the limiting depth of nodal axis for different types of grades of steel. If you consider Fe 250 grade, for Fe 250 grade we are taking the limiting depth of nodal axis as 0.53 into D, as well as if you take the limiting depth of nodal axis for Fe 415 grade of steel, we are taking it as 0.48 into D. For Fe 500 we have taken it as 0.46 into D, where D is the effective depth of the section. Today we will see about the types of sections. That means based on the depth of the nodal axis, based on the depth of the limiting depth or maximum depth of the nodal axis, we are having three types of sections. These sections are balanced section, under reinforced section, as well as over reinforced section. In today's class, we will discuss about what is meant by balanced section, what is meant by under reinforced section, what is meant by over reinforced section. If you see in previous lectures for working stress method, already we have discussed about these types of sections. In working stress method also we are having balanced section, under reinforced section, as well as over reinforced section. In the previous condition we have seen about the different types of sections in very less, in the very little quantity. In this today's class we will explain very lengthy. That means the all terms, what are the different types of sections. Today we are discussing here our balanced, under reinforced and over reinforced section in limit state method. Okay, basically if you see here, this is our regular concrete beam. For this regular concrete beam we are having total depth of the beam as D, already you know, and where B is the width of the beam or width of the section. Again, if you consider from top of the compression fiber to the center of the steel bar, we are taking it as effective depth small d, where effective depth, it is the depth of the concrete from top of the compression fiber to the center of the steel bar. And if you see here, already we have discussed about the clear cover and effective cover. Again here I want to explain what is meant by clear cover and what is meant by effective cover. If you see here, from this bottom of the steel bar to the bottom of the concrete, what you are providing to the cover, that it will be called as a clear cover. Effective cover means half of the central distance of the bar plus the clear cover, if you add, that it will be called as a effective cover. That means effective cover equal to clear cover plus half of the diameter of the bar. That means half of the diameter of the bar. From bottom of the bar to the bottom of the concrete we are taking it as clear cover. Again from central distance to bottom of the concrete we are taking it as the effective cover. These terms we are already discussed. Again if you see here, this section we have drawn here. That means where the section here we have drawn one section here. If you observe here, this is the section where that nodal axis that divides the compression phase as well as tension phase. Where nodal axis, it is the section that divides the compression phase as well as tension phase. And if you observe here, first this section we are taking it as balanced section. That means if you observe here, this is our neutral axis. Neutral axis where it divides the compression phase as well as it divides the tension phase. Here they represented the concrete also. This concrete maybe it will become for over reinforced section. The concrete will become come for the over reinforced section as well as for the under reinforced section. First, if you see here, this section it will be called as the neutral axis that divides the compression phase as well as the tension phase. If you see here, where this XU limit, if you observe here, this is the XU limit and this is the XU as well as this is also one type of XU. If you check here in balanced section, in balanced section we are having the stress block parameter from top of the compression fiber to up to this depth, where XU it will be called as the actual depth of the neutral axis, where XU it is called as the actual depth of the neutral axis. This XU how we are calculated means we have calculated the total compressive forces as well as we are calculated the total tensile force. Based on total compressive forces and based on the total tensile forces, we are calculated the XU value as well as limiting depth of the neutral axis. That means based on the grade of the steel, we have also calculated the limiting depth of the neutral axis. That limiting depth also we have calculated. That limiting depth of the neutral axis XU limit equal to K into D, where K is the neutral axis constant and D is the effective depth of the cross section, where XU is the actual depth of the neutral axis that calculated from the total compressive forces and the total tensile forces. If you see here, for balanced depth, for balanced section, compressive force is equal to tensile forces. That means neutral axis that divides the section at this point, and at a particular point that XU it will be we are taking as at this particular point. Again, if you come to the under reinforced section, we will discuss what is meant by balanced section, what is meant by under reinforced section, what is meant by over reinforced section. First this diagram, first I am explaining. If you check here, what we are observing means here this is the neutral axis for the balanced section. Again, if you observe here, the neutral axis for under reinforced section, it is going to somewhat higher. That means it is above the balanced section. What is the neutral axis you are provided for the balanced section? That neutral axis it will be changing its position to some higher side. That means the neutral axis changes to this depth. That depth what we are providing, that it will be called as a limiting depth of neutral axis. If you observe here, for balanced section, the neutral axis is above the neutral axis is, it divides the center of the section. That means compression phase as well as tension phase. Again, if you observe the under reinforced section, in under reinforced section, what happening means the depth of neutral axis what you are providing, that is shifting this position to somewhat higher side. That means the compression phase and tension phase, that the distance is changing, where XU is the neutral axis that divides the compression phase and tension phase. If you see here, for balanced section, the concrete is this much position and steel is this much position, whereas under reinforced section the concrete is this much position and this steel is from this to this much position. This is for under reinforced section. In under reinforced section, what we are doing means we are providing the limited amount of steel. Due to limited amount of steel, the maximum strain will come into the steel first. Hence why the depth of the neutral axis it will may decrease. Okay, again we will discuss about this concept. Again, if you check here over reinforced section, in over reinforced section what happening means, if you observe from this balanced section, the stress block parameter what we are providing, it will be coming to the below of the balanced section. The nodal axis what you are providing, that is coming down to the balanced section. That means the limiting depth of the nodal axis is increasing compared to the balanced section. These are the diagrammatic representation for the what is meant by under reinforced, what is meant by over reinforced, and what is meant by balanced section. If you check here for balanced section, where XU is the actual depth of the nodal axis, that actual depth of the nodal axis we are taking it as from total compressive force equal to total tangential force, as well as based on the grade of steel we are calculating the limiting depth of the nodal axis. If the limiting depth of the nodal axis will be above the nodal axis of the balanced section, that it will be called as a under reinforced section. Whereas the depth of the nodal axis you are providing below the balanced section of nodal axis, that it will be called as a over reinforced section. Okay, now we will see some calculations how the balanced section, not over reinforced section, under reinforced section will be vary based on the various type of stresses. First, what I am doing here means, first I am taking here it as balanced section. First I am taking it as balanced section. For balanced section, what is the meaning of balanced section means, in balanced section the compressive stresses as well as the tangential strains will comes to yield simultaneously at a time. That means if you take any reinforced concrete member and if you apply the load, due to this application of the load, the strain in concrete as well as the strain in steel will lead at a same time, simultaneously will yield. Due to this simultaneous yielding of the member, the structure it will may collapse. If you provide or if you design the section in such a way that it will be called as a balanced section. Again I am repeating, balanced section, it is the section where the concrete and steel will fail simultaneously at a particular time, as well as the compressive stresses developing in the concrete, the tangential stresses developing in the steel are greater than the permissible stresses. First I will write here the compressive stresses, what you are getting, it will be greater than equal to the compressive stresses of the permissible concrete. The permissible stresses of concrete, the permissible stresses of steel, we are taking it from IS 456 2000 code book. For different types of grades of concrete, the permissible stresses it will may vary. Already we have discussed about the characteristics, design strength. Okay, based on those concepts, we will take the permissible stresses. Again, if you take the tangential strain of steel also, it will be greater than or equal to the permissible tangential stresses. That means concrete and strain in the steel will both get failure at simultaneously. Due to this simultaneous failure, this section will may get collapse. And if you observe here where sigma c permissible, sigma t permissible, these two values are we are taking it from IS 456 2000 code book. Okay, from table 18 we are taking these values, sigma c permissible values and sigma t permissible strain. Again, if you check here for balanced section, what we are getting means we are getting XU equal to XU limit. For balanced section, we are getting XU equal to XU limit. That means this XU is the actual depth of the nodal axis. That actual depth of the nodal axis we are calculated from the total compressive force as well as we are calculated from the total tangential force. This is the XU we are calculating. Again, if you take XC limit we are having the formula of K D. This XU limit value for different types of grades of concrete, this it will be vary. We have already seen for Fe 250, Fe 415 and Fe 500. Based on this concept, we'll calculate whether the section is balanced, under reinforced or over reinforced. This calculated depth of nodal axis, it will be equal to the limiting depth of the nodal axis. That section it will be called as a balanced section. That section it will be called as a balanced section. In balanced section, the concrete and steel will may get failure at simultaneously. Concrete and steel will get failure at the simultaneously. This is about the balanced section concept. Permissible stress in concrete will be greater than, compressive stress in the concrete will be greater than the permissible stress of concrete. Compressive strains or tensile strains in the steel will be greater than the permissible tensile strain of the steel. Where XU equal to XU limit, where XU, this value we are calculated from the total compressive force and total tensile force. That XU limit we are calculating, that means limiting depth of nodal axis. This both it will be equal to the section, that will be called as a balanced section. If you observe here, this XU, if you observe here, this XU and XU limit are both are equal. Hence why this section we call it as a balanced section. Next we will discuss about the under reinforced section. We will discuss about the under reinforced. We will discuss about the under reinforced section. Okay. Under reinforced section. What is meant by under reinforced section? Under reinforced section, it is the section in which we are providing limited amount of steel, or in which we are providing less amount of steel compared to the balanced section. If you take balanced section you are providing some steel. Whereas if you consider under reinforced section, we are keeping some less amount of steel compared to the balanced section. Due to providing less amount of steel into the concrete, the load what you are getting, that loads will be taken first by the steel. Hence steel will get strain first. That means steel will first gain strains. Hence why steel will may failure first. That means the maximum strains will be taken by the steel. If you observe here in under reinforced section we are providing the limited amount of steel or less amount of steel compared to the balanced section. Due to this less amount of steel, the strains will came to the steel first. Steel will may leads to failure. That's why we are calling it as a under reinforced section. If you observe here in under reinforced section, the strains we are getting will be more than the strains of the permissible limit of the steel. According to IS 456 code book, for different types of grades of steel, we are having the permissible strain or permissible stresses in the steel. For this under reinforced section, the stresses or strains coming in the steel will be greater than the permissible strain of the steel. Again, if you see the compressive stresses or compressive strains what we are getting in the concrete, it will be less than equal to the permissible compressive stresses. That means what we are observing here means the steel is taking the strain first, after the strain is taken by the concrete. If you observe here, the loads what we are getting in the concrete, it will be less than the permissible stresses. Hence why concrete won't get failure in this section. Again, if you observe in this section, due to less amount of steel, the load will be taken by the steel. Hence steel will may lead to yielding first. And again, for this under reinforced section, what we are observing is the actual depth of the neutral axis what we are providing, it will be less than the limiting depth of the neutral axis. For under reinforced section, what you are providing, this actual depth of the neutral axis will be less than the limiting depth of the nodal axis. Again, for actual depth of the nodal axis, we are taking total compressive force, total tangential force, we are calculating XU. Again, for XU limit, if you take FE 250 grade, FE 415 grade, FE 500 grade, XU limit again we are calculating. That it will be XU limit equal to KD. Based on the grade of steel, the XU limit value it will may change. The actual depth of the nodal axis what we are providing, it will be less than the XU limit. That section it will be called as a under reinforced section. In under reinforced section, what is happening? Strain is first coming in the steel and the failure is due to strain in the steel. It will be called as a ductile failure. That means here we are taking it as a ductile failure. DUCTILE, ductile failure. That means strain in the steel coming first. Due to strain coming in the first, the failure what we are getting in the steel will be called as a ductile failure. Due to this ductile failure, steel will may failure first. Steel failure may occur. Steel failure is first. Steel failure is first. And you will get an alarm. You will get an alarm. You will get an alarm. That means due to application of the load, strain will leads to ductility. Due to ductility yielding property, we will observe that cracks and we can vacate that building. Due to this vacation, the loss of life and property may not damage. Hence, for majority of section, for designing, we will use either balanced section or under reinforced section. This is the concept for under reinforced section. If you check here under reinforced section, this is our actual depth of nodal axis for the balanced section. Actual depth of the nodal axis. Whereas if you check here, the XU it will be less than the limiting depth of the nodal axis. The total compressive force, total tangential force what we are calculating, based on that we are calculating the depth of the nodal axis. This depth of the nodal axis will be less than the limiting depth. That means the compressive force and tangential force have some limited depth. Some compressive force we have to take, some tangential force we have to take. Based on this concept that compressive force and tangential forces, the phase it will be nodal axis, it will be changed. Based on that we will derive it as under reinforced, over reinforced and balanced section. Next we will discuss about the over reinforced section. Next we are having the over reinforced section. Over reinforced section. Over reinforced section, it is the type of section in which we are providing the maximum amount of steel compared to the balanced section. Over reinforced section, it is the section in which we are providing the maximum amount of steel compared to the balanced section. Due to this provision of maximum amount of steel, the area of concrete it will be get reducing, or the area of concrete will be less. Due to less area of concrete we are providing in the structural member, due to this application of the load, concrete it will may get failure first. Okay, understand? In over reinforced section, what we are doing means we are providing maximum amount of steel. Due to this provision of maximum amount of steel, the cross sectional area of concrete is getting reducing. Due to less cross sectional area of concrete, the load what you are applying, the load will be taken by the concrete first. The load will be taken by the concrete, or concrete will may get failure, which is not advisable to design the such type of members by providing maximum amount of steel for the section compared to the balanced section. Again, if you check here, the maximum compressive strains or stresses in the concrete will be greater than the maximum compressive stresses coming in the concrete permissible. That means for permissible stresses, the stresses what we are getting in the concrete is getting first. That means compressive strains in the concrete is maximum compared to the permissible stresses. That means suppose if you take here the permissible stresses as 5 megapascal. whereas the maximum compressive stress in the concrete it will be as 10 megapascal. Hence why the section will may failure. The limiting value it will be 5 megapascal, but we are giving this load as 10 megapascal. Hence why concrete will may failure. Again, if you check here, the tensile strain or the tensile stress what we are providing in the section, it will be less than the permissible tensile strains of the steel. That means due to more provision of steel, the load what you are getting, that load it will be less than the permissible stress. That means suppose if here the steel will take care by the permissible stress as 140 Newton per mm square, whereas this tensile strain in the steel will coming only 100 Newton per mm square. That is the concept. And again, if you check here, for this over reinforced section, what is happening means the actual depth of the neutral axis will be greater than the limiting depth of the neutral axis. That means the stresses in concrete is getting first. Due to stresses developed in the concrete first, concrete is a brittle material. Due to this brittleness, concrete will fail immediately. Due to this failure, which may leads to the loss of life and property. If you observe in this diagram, if you observe in over reinforced section, actual this is the balanced section. That means this is the balanced section. That means this is the actual depth we have to provide for a section. Whereas due to more amount of steel we are providing in the section, hence what it will happen means the stresses will develop in the concrete is more compared to the stresses developing in the steel. This is the diagrammatic representation for the over reinforced section. Okay, the same here also will take it as it is a brittle failure. Okay, it is a brittle failure. Due to this brittle failure, the concrete section what we are getting, it won't give any alarm. That's why we are not providing any over reinforced section for different type of sectional members. Again, the stress block diagram I represented for the what is meant by balanced section, what is meant by over reinforced section. This is the same diagram I will explain by drawing with the same cross section. Suppose this is your rectangular beam and this is the total depth of the beam. Here we are providing the area of steel as AST. Okay, see, this is your neutral axis, and where B is the width of the section, C is the compression phase, and T is the tension phase. If you observe the stress strain diagram, okay, if you observe the stress strain diagram, here the neutral axis is in between. That means it divides the same compressive forces and tangential force. That means here this is the balanced section. Again, if you observe here, in under reinforced section, what we are doing in under reinforced section, the depth of the neutral axis it may shifting to some higher position. Why? Because we are providing the less amount of steel. Due to less amount of steel, the neutral axis depth, the limiting depth, it will may vary. That means for under reinforced section, the neutral axis will be in this position. Neutral axis is in this position. This is for under reinforced section. And again, if you take one more section, that is over reinforced section. If you observe here for over reinforced section, If you observe here for over reinforced section, the depth of the nodal axis what we are giving, it will be below the actual depth of the nodal axis. If you observe here for under reinforced section, the depth of the nodal axis is above the balanced section. In this condition, we are calling it as under reinforced section. Whereas for over reinforced section, the depth of the nodal axis is below the section. This section will be called as a over reinforced section. Okay. Up to now, this is the concept for different type of sections. Today's class we have discussed about the what is meant by balanced section, what is meant by over reinforced section, what is meant by under reinforced section, as well as we have discussed about the permissible stresses in concrete, permissible strains in the steel, maximum compressive stress in the concrete, maximum compressive strain in the maximum tensile strain in the steel. In next class we will discuss about the how we have to design different type of sectional problems. This step by step procedure we will discuss in last class. Thank you.